So yesterday we graphed linear inequalities and equations. Today we're going to be graphing systems of inequalities. From Algebra 1, do you guys remember what a system is? It's not just one, it's more than one equation put together. Okay, so a system has two or more equations. So you guys remember that now? We would get two equations lined up underneath each other. Kind of. Okay, you'll remember when you see them. So, what does the graph of a system of linear inequalities look like? A graph just shows all of the solutions to the system. So everything that is possibly a solution will be shown on that graph. So that's what the graph of a system is. What about the solution to a system? On the graph, the solution is going to be the common shaded region that overlaps all inequalities. So we're only looking for the common shaded region here. So that means that it's only going to be the area that both are shaded in. Okay? Alright, so let's look at example 1. This is what a system looks like. We have two equations on top of each other. Example 1, all we want to do is check whether each point is a solution set of the system. So we have 2 points that we're going to check here. And we are going to we want to check to see that it is a solution. So how do I check that a point is a solution? You just plug it in and check for a true statement. But we have two inequalities this time. So I'm going to have to plug in this point twice. And it needs to be true for both of them. Okay? So let's plug it into the first inequality first. So that's going to give me 4 times 3 plus 2 times 2 greater than 6. 4 times 3 gives me 12, plus 2 times 2 gives me 4 greater than 6. 12 plus 4 gives me 16 greater than 6. Is that a true statement? Yes, it is. So it works for the first one. So for the first one, we're good. Now what we're going to do is take that same point and plug it in to the second inequality. And we need a true statement for both. Okay? So I have 2y, so that's 2 times 2 greater than x, which is 3. 2 times 2 gives me 4 greater than 3. Is that a true statement? Yes, it is. So, is 3, 2 a solution to this system? Yes, it is. It works for both of them, so yes, 3, 2 is a solution. Okay. So let's try it with the point -1, 4. I'm going to take this guy and plug it into the first one. 4 times -1 plus 2 times 4 greater than 6. 4 times -1 gives me -4 plus 8 greater than 6 is what we want. -4 plus 8, that gives me 4 greater than 6. Is that a true statement? No, it's not. So we already know it doesn't work for the first one. Let's plug it into the second one just to check for kicks. So that's 2y, 2 times 4 greater than -1. So that's 8 greater than -1. Is that a true statement? 8's not bigger than -1? It is a true statement. So we have one true and one false. So is that point a solution to the system? No, it's not, because it doesn't work for both of them. So the answer is no. It has to be a check mark for both. Make sense? Okay. So let's actually graph some of these things. Graphing is going to be the same as what we just did in last night's homework, but this time we're going to be graphing 2 lines. Okay? So looking at example number 2, we want to graph y greater than or less than or equal to 3 and y greater than or equal to 2x plus 7. Okay, let's graph the first line. I'm going to do it in purple. So y less than or equal to 3, that's what we want. Okay, is this slope-intercept, standard form, or one of our special lines? It's a special line. Which one is it? Is it vertical or horizontal? It's horizontal. Okay, remember y is always staying the same here because we have y less than or equal to 3. So y stays the same, the x is what's changing. So at positive 3, we're going to draw a horizontal line. 1, 2, 3. Is it going to be a solid or a dotted line? It's a solid line because we have that less than or equal to. So draw a solid horizontal line through 3. Okay, now we do need to do some shading here. I want you to do this in pencil very lightly because we are going to be doing some erasing. So since this is y less than or equal to 3, am I shading above the line or below the line? Good, below. So shade very, very lightly below the line. Okay, very, very lightly. Okay, now let's shade the second one. We have y greater than or equal to 2x plus 7. Slope-intercept, special case, or standard form? Remember, standard is x and y on the same side. Slope-intercept is y by itself. Slope-intercept, right? What's the y-intercept? Positive 7. So let's put a point there. 1, 2, 3, 4, 5, 6, 7. And my slope is positive 2 over 1. So I'm going to go up 2 and to the right 1. Is that going to be a solid or a dotted line? That's also solid because of the equal to underneath. So let's draw a solid line. And is this one shaded above or below? This one's above because it's greater than. So shade lightly above. And now let's look at our answer here. Okay. Remember in example 1, we checked a point and it had to be true for both inequalities. So we can only pick points that are true for both inequalities. So where do you think my answer is going to be? Is it going to be the whole thing, or is it only going to be where they overlap? It's only going to be where they overlap. It has to be true for both lines. So we can erase everywhere where it doesn't overlap. So that's in between the orange and the purple line. That's where our answer is. So our answer is actually just that little space right there. Okay, so our answer is actually only in between the purple and the orange lines. Your answer is only ever going to be where it overlaps. Okay? Alright, example 3. We're dealing with 3 inequalities this time. It's still a system because it's more than 1, but we have 3 this time to worry about. So we have y less than or equal to 6. We have y less than or equal to 5. And we have y greater than or equal to x plus 3. So we're going to graph 3 lines here. The orange and the green lines look like special cases to me. Are these horizontal or vertical lines? Horizontal. So this one is y less than or equal to 6. And it's a solid line because it has the equal to. So 1, 2, 3, 4, 5, 6. It's going to be this way. Okay, that one is shaded below, so I'm going to just lightly shade below. Okay. Y less than or equal to 5, vertical or horizontal? Also horizontal. So that's one space below, and it is also solid because it has the equal to. Okay. since it's less than or equal to, is that one shaded above or below? Also below. So let's shade below the green line. So everything below the green line is pretty dark right now. Last one. What form is this in? Slope-intercept. What's my y-intercept? Positive 3. So let's go up 1, 2, 3. What's the slope here? I have just an x. Do you guys remember? There's invisible 1 right there. So I go up 1 over 1. Is that a solid or dotted line? Also solid. And this one is y greater than or equal to x plus 3. So is that above or below? Above. Good job. So lightly shade above, but I am only seeing one place where all 3 overlap, and that is this spot right here. So my answer actually lies below the green line, because remember, everything below the green line is also part of the orange answer. So it's below the green line, but above the purple line. Okay, it can't be this space in between the orange and the green, because the green doesn't cover that space. Does that make sense? It's just below the green line. So this spot between the orange and the green isn't covered by the green stuff. So it's just this triangle of stuff in here. So that is your answer between the green and the purple lines. Does that make sense? Yes.
So for
example 5. Last one. We have 0.05x, 0.02y, less than or equal to 20. We have x greater than or equal to 2. And we have y greater than or equal to 3. This one, the orange one, is going to require a little bit of work. Why don't we do the 2 easy ones first, and then we'll do the harder one. So x greater than or equal to 2. That's a special line, is it not? Is it the vertical or the horizontal? It's the vertical. So that is greater than or equal to positive 2. So it's a vertical solid line at positive 2. Greater than or equal to, so it's going to be to the right or to the left? What's bigger than 2, to the right or to the left? Right. To the right. Right there's 3, 4, 5, 6. So let's shade that very, very lightly, not too heavily. Okay. Purple one. Y greater than or equal to 3. Vertical or horizontal? Horizontal at 3. So 1, 2, 3. And that's also solid. 1, 2, 3. Okay, and that's greater than or equal to. So is that above or below? Above. So light, 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 but it's getting dark. Our answer is going to be somewhere in this square, right? So now it all depends on that guy right there. Okay. So we know that it's somewhere in that square. I'm going to rewrite this down here and do a little bit of work first. 0.05 plus 0.02y less than or equal to 2. So my graph is going to go away first, just a second. I don't know about you guys, but I'm not really a huge fan of decimals. Anybody else? Decimals suck. Okay, fractions are way better, but we're not going to deal with fractions either. How can I make this guy a whole number? Move the decimal 2 spaces, which means I have to move this decimal 2 spaces, which means what do I have to do to this guy? Also move it 2 spaces. What am I really doing when I'm doing that? Multiplying by what? What moves it 2 spaces? We're really multiplying by 100, right? If we're multiplying this guy by 100, which you have to do that side by 100, it will move my decimal over to make whole numbers. So 0.05 times 100 gives me 5x plus 2y, less than or equal to 200. It's going to make things a little nicer for us. We're going to run out of room though, but that's okay. So then we can do our t-chart. So let's draw our t-chart. X-intercept, Y-intercept. X-intercept, we cover up the y, so that's 5x equals 200. Divide by 5. So x equals 40. And do the same thing here. So we would have 2y equals 200. So y equals 100. Oh my goodness. Whoa, mama. Okay, so those are all the way out here, all the way up here. Since we plug those in, we could move our decimals back our 2 spaces. So we would have 0.4 and 1, right? Because of, now let me do some quick mental math here. So it doesn't matter, actually. It's still 40 and 100. So that's going to be something all the way out here, something all the way up here. Basically, our line is going to be, I don't know, I'm just going to draw something like this. And it's less than, right? So our answer is basically going to be everything below that orange line, but between the 2 green and purple lines. So our answer is going to be somewhere in there, but below the 2 lines.